So in question number 7, the first one is from trigonometry. We'll take the LHS and we'll prove this one. So RHS is equal to 1. Tan square A by tan square A plus 1 plus cosec square A minus 1 by 1 plus cot square A is equals to 1. So let's take LHS and we'll prove RHS, that is 1. Okay, in this if you take left hand side, we should know trigonometric formulas and properties. You can do easily. Okay, so LHS is tan square A by and tan square A plus 1 and plus cosec square A minus 1. Numerator is cosec square A minus 1 by and 1 plus cot square A. Okay, this is LHS. And we know the formulas: x square minus tan square is equal to 1, cosec square minus cot square is equal to 1. So trigonometric formulas, if you let me write the formula here. Two formulas, that is sec square A, sec square theta minus tan square theta is equals to 1. Trigonometric identities. And one more is cosec square theta minus cot square theta is equals to 1. Okay. These two trigonometric identities we'll use in this. Then here tan square A is as it is. Numerator is tan square A by tan square A plus 1 is sec square A. Okay, sec square minus tan square is 1 means 1 plus tan square is sec square plus and cosec square minus 1, that is cot square A by 1 plus cot square is cosec square A. So that both the trigonometric identities only applied here. Again from this, and just see here again tan by sin theta by cos theta is tan and 1 by cos is sec. So if you apply more, sin theta by cos theta is equals to 1, sin by cos is tan, and reciprocals, sec reciprocal is cos, cosec reciprocal is the sin. That formula also will apply. So tan square A, that is sin square A by cos square A divided by sec square A, that is reciprocal is 1 by cos square A. So 1 by cos square is sec square A plus cot square A is cos square A by sin square A and cosec square is 1 by sin square A. And if you cancel cos square cancel, denominators are same, you can cancel this, and remaining is sin square A is this side plus cos square A, and one more identity is sin square theta plus cos square theta is 1. So sin square A plus cos square A is 1, that is the RHS. Very simple. So LHS we are taken and prove RHS. So hence proved. Right, so we can prove in this way. And see the next question. This is from geometric progression. For what value of x the numbers minus 2 by 7 comma x comma minus 7 by 2 are in the geometric progression GP. So we'll use in GP formula when A, B, C are in GP, what to take. So see here. So given series, so given data is minus 2 by 7 comma x comma minus 7 by 2 are in GP. And if you see the formula for this, if A comma B comma C are in GP, then B square is equals to AC we can write. So it's middle number, B square is equal to AC. So this is the property we apply for this problem. Now according to this problem, x square. So according to this, x square, because middle term is x square is equals to minus 2 by 7 into minus 7 by 2. Right? And 2 by 7, 7 by 2. So 2 and 7 cancel, minus 1 to minus 1 is plus 1. So from this x square is equals to 1, then x is equals to plus or minus 1. So plus 1 or minus 1. That's the value of x, two values. So simple problem it is. And let's see the next one. Okay, this is cyclic quadrilateral problem. In the given figure alongside ABCD cyclic quadrilateral, you should know the properties in which BC is equal to CD. Okay, BC and CD are same, and TC is a tangent to the circle C. Okay, TC is tangent, and this one chord. DCE, angle DCE is 112 degrees. O is the center of the circle. Find DCT. DCT. So this angle you should find out. So angle DCT we need to find out, and angle BOC. BOC. So in case if you join this angle BOC also we should find out these two angles. Now let's take the problem and solve. So let me draw the diagram for understanding clearly. Let's take the circle. And ABCD is a cyclic quadrilateral. ABCD cyclic quadrilateral. So A to B, B to C, and CD, DA. Okay, this is cyclic quadrilateral, and for CD is the chord and CT is tangent. So it's a tangent, and by extending this line, the same line only is extended. Okay. So this is the given diagram, and O is the center of the circle. Let's take O here. O is the center of circle. Okay. So A, B, C, and D. And according to problem, BC is equals to CD. These two sides are same. And let us take this is the tangent T, point E, and DCE. So total angle is 112 degrees. 112 degrees. Okay. Now, so what we should find out? Angle DCT. DCT we need to find out. So we should find out this angle. And O is the center of circle. So let me join B and D. Join B to D and BOOC, because we need to find out angle BOC also. So whenever you observe the properties, BC is a straight line. If it is 112 degrees, the remaining angle you can find out. That is 180 minus 112. Okay, by joining 112, 180 minus 112 is 68. So from the given figure, from the given diagram or given figure, we can write that is angle DCB. So angle DCB is equals to 180 degrees minus 112. So 112 is DCE. Angle DCE, because straight line angle is 180 degrees, and 180 minus 112 is 68 degrees, right? So angle DCB is DCB. So this is the 68 degree. And if you observe triangle DBC is the isosceles triangle, because CD is equal to BC, then this angle and this total angle must be equal. And some of the angle in a triangle, some of the angles in a triangle is 180 degrees. These two should be equal. Then you can share the both. Then angle DBC. Therefore, angle DBC or BDC, these both are equal. That is equals to half of the 180 minus 68. From total 180, 68 you subtract. That should divide for both. So 1 by 2 into 180 minus 68 and half if we do, that is 112, 56. 56 degrees is each. So this is the 56 degrees and this is also 56 degrees. Now see the property. We should find out the first one, DCT. Okay, DCT. Now the CD is the chord and this is tangent. So if you see the same segment, angles in alternate segment, so this angle should be equals to other side segment. So if it is 56 degrees, DBC is equals to DCB. So this also must be 56 degrees. That is using angles in alternate segments. So first one, DCT. So angle DCT only is nothing but angle DBC. DBC, that is already 56 degrees. So because of this, angles in alternate segment are equal. Angles in alternate segment property applied. Okay. And there is a tangent. So anytime if we take the chord to this tangent, so whatever angle, okay, if you observe here, so this angle should be equal to other side segment, that is DBC. That's right. This is 56 degrees. And next one we need to find out the angle BOC. And if you observe this circle, angle BOC, so BC is the arc. This is whatever angle subtends at the center is double to angle subtended at the remaining part of the circle. That means this angle BOC should be double to angle BDC. Okay, 56. So double of the 56 only angle BOC. Therefore, the second one is to find out angle BOC. That is equals to 2 times angle. So what is that angle BDC? BDC. That is equals to 2 into 56. That is 112 degrees. Okay. This is angle at the center is 2 times angle at the circumference concept. Okay, just I'll write the condition if you want to remember. Because angle at the center, angle at the center is equals to 2 times into angle at the remaining arc, remaining part of the circle, that means remaining circumference. The same arc only we should take. Then it's a clear. If we observe angle at the center, this should be double to angle at the subtend of the remaining part of the circle, so remaining circumference, right? So we can find out. So DCT is the 56 degrees and angle BOC is 112 degrees. Right, so we can solve this paper in this way. Simple question. Now let us see question number 8 and we will solve these problems now.